The purpose of today's session is that we will understand the basic operations a router and switch might do over there, and we'll try to understand what are the ACLs, because this is very important the moment we move into the cyber or the SOC part over there. Okay, because this is helping you to understand the network part in detail. We have a couple of classes on the Linux as well too. Okay, so we might have a couple of exercises on Linux as well too. There further as well. Okay, so let's see now. If you want to try that on the home, you will need to get packet tracer at your environment there. So we have Cisco packet tracer, where we actually can practice all the network operations in detail. Let me just log in. Okay, so we need to understand first what kind of operations a router or a switch can generally do, so we understand why and how we are using them into different organizations there. Okay, so first I will start with the switch part. Okay, because we understand what is IP address, how does the devices are connected over there, correct? So for example, let's try to understand. You have these three computers. Okay, I'll take a switch. Here we have multiple switches over there. The basic one is 2960, which is something we use at almost every place. Okay, and now you have the cabling. What cable generally you need to connect over there? So you need to remember that in the real time, whenever you have different devices, then we have straight cable. Need to use this one, the straight one. And when the devices are going to be the same kind of the devices, you need to use this dotted or the cross cable, we call it. Okay, so I just connect them quickly. A PC is connected to switch. This is when any person is going to the office and connecting the cable to their cubicle. Okay, in back end it is actually connected to a switch, to be specific. So this switch can connect 24 people at a time. Okay, now the one important thing is, if a switch is gonna be connected and gonna provide the communication there, then how does the packet flow? How does the communication actually occur? Okay, so before the computers could work, I will be having the IP address mentioned there for every machine, correct? So I'm using just one network here, so I'll type 192.168.1.1. Okay, here I'm gonna type 1.2, and this is going to be 1.3. Okay, so this is going to be 1.3 now. So now I need to see how does the packet actually flows into the network there. Okay, so for the packet flow, what I did here in the simulation, I type here ping 192.168.1.3. Okay, so if you need to see the same thing on the OSI layer architecture, on application layer, I open the application. Presentation and session layer does not happen much things, as we are doing just ping. We move further to transport layer. I use ping. So ping is a TCP protocol. Okay, so the packet will be segregated, will be breaked. That part happens. And now we comes to network part. So at the network part, we add source IP and destination IP. Correct. Source IP is known to my computer. Destination IP I have provided 192.168.1.3. Okay. Now you come to the next layer, which is data link layer. What is required? Source MAC and destination MAC address. Now the source MAC must be known to my computer already, but my computer does not know the destination MAC address over there. Correct? So the packet won't form. If I just press enter, did you see? There are two type of the packet has been created. So the packet which I'm going to send ICMP, it do have data on layer 3, which is source IP and destination IP, but it does not have any data on the destination side. Correct? On the layer 2 to be specific. L3 data is there, but L2 data is not there. Now, until unless the L2 data is not there, the communication could not happen. Okay. So what will happen then? So switch uses a protocol which is known as, so you can see this packet will get on hold. This is the ping packet.